We have just examined the serial connected resistors, equivalent resistors resistance, how we are going to calculate it. We examined that. Now we have here in this circuit 4 resistors are connected in serial, in parallel. And can we find the equivalent resistors resistance value? That means our aim is to find this R equivalent. That is, we would like to find out. So these are in parallel. Why is that? Because the terminals are connected, those elements terminals are connected in such a way that at the end we've got one single node pair. So there is one node pair here, therefore these 4 resistors are connected in parallel. So when you connect it parallel connected elements voltages are the same. Let's prove this first. So in order to do that, we need to choose the reference, voltage reference for these resistors. Let's choose this. I have chosen the same direction, the voltage values, voltage references, to make it a bit simpler. Now if you write the Kirchhoff voltage law equation for this mesh, so we need to choose a mesh direction. So assume that we have chose this one. According to passive sign convention, this element current reference is this way. This direction is opposite to that direction, therefore is Kirchhoff voltage law equation minus Vs. So this direction and this passive sign convention, this element current reference is from plus to minus, therefore the sign is going to be plus VR1 is equal to 0, then VR1 is equal Vs. So similarly, let's change the order. Let's say this is Vs is equal VR1. So if you consider this mesh now, this is not mesh, yes, because it includes another loop in it, so this is not mesh. But if you write the Kirchhoff voltage law equation for this loop, you're going to end up VR2 is equal Vs, VR3 equal VR4. So that conclusion tells us that parallel connected elements voltages are the same. It doesn't change. So for this case, this is independent voltage source voltage, that is. So another thing that we could write here in order to calculate that equivalent resistance value is this is the current. So this element currents are this I1, that is I2, that is I3. I cannot choose these current references randomly anymore because I've got to choose it according to passive sign convention, otherwise I'm going to face with some problems that I can't solve. So if you write the Kirchhoff current law equations for this node, now this is just one node we are seeing here. This current direction is towards the node, that's why minus I. So the other currents are coming out of the node, therefore the sign for these currents are going to be plus. So I1 plus I2 plus I3 plus I4 is equal to 0. So if you move it to the other side, so I is equal I1 plus I2 plus I3 plus I4. Now I am saying this is a resistor current, isn't it? This is this current. So if I use the definition relation of this resistor, it's going to be 1 over R1 Vs. I know VR1 value is equal to Vs, so this is what I have done here. And then for the others, similarly, 1 over R2 Vs plus 1 over R3 Vs plus 1 over R4 Vs. So if we take these two Vs parentheses, 1 over R1, 1 over R2 plus 1 over R3 plus 1 over R4 multiplied Vs. Now if you consider this now and say that 1 over R equivalent. So we are saying now, so if I write it in this form now, I is 1 over R equivalent Vs. That means I times R equivalent is equal Vs. That is a definition relation of a resistor of which resistance value is this, isn't it? So this resistor is this Vs, R equivalent, which is this, then this current is this, isn't it? So on the other hand, left hand side circuit current is this. So that is that current. And this current here, make it red, is this current. So they are the same. So that means this is the equivalency definition. So those two currents equal. So if you took these four resistors off and put that equivalent resistance in, this current does not change. So we have calculated what it is. So RQ, what is the RQ? We calculate 1 over RQ. So if you want to calculate that RQ, that means you're going to do this. Calculation of this, you're going to end up a formula. But if you consider just two of them, if two resistors are connected in parallel, it's going to be 1 over R equivalent is equal 1 over R1 plus 1 over R2. So if you do the calculation, R equivalent is equal R1 multiplied R2 over R1 plus R2. You can say something about this result. How you can say it? I can say that if there are two resistors are connected in serial, then equivalent resistors resistance value is smaller than the smaller resistors resistance value. A bit long, but if I give an example, you might understand it more clearly. So let's say this is 100 and this is 50 ohms. Then we are saying the equivalent resistor, which is the parallel connected resistors resistance, is going to be less than 50 ohm, less than the smaller one. So how you can check it? If it is the smaller resistor that we've got, look at the other side, this ratio. This ratio is smaller than 1. Why is that? Because you are dividing R2 something which is bigger than R2. So this is less than 1. If this is less than 1, that means R equivalent resistor resistance value is less than R1. So that means smaller, this equivalent resistor resistance value smaller than the smaller resistor's resistance value. That is a conclusion. You can check yourself whether you made a mistake or not while we are calculating the equivalent resistance value. So what is the use of all these things? One of them is the analysis. It is useful. Why is that? Because in the analysis in general we are writing Kirchhoff voltage law equations, NE minus ND plus one of them, and then we are writing Kirchhoff current law equation, ND minus one of them, the independent ones, and NE element definition relation all together, two NE unknowns, two NE equations. Now I am saying if there are two resistors connected in parallel, if you replace this resistance with the equivalent resistor, then one of the mesh disappears. That means one of the Kirchhoff voltage law equation that you're going to write is not going to be seen when you replace it with the equivalent resistor. So if you got more than one parallel connected elements within the circuit, for each pair, the number of equations you're going to write is going to be less. So that means this number reduced, this number reduced, the number of equations that you're going to solve has been reduced. That's why it helps to the analysis problem. Another thing is, if you got non-available resistance value in the market, you might get it from the available resistor values. How you can get it? So maybe it is better to explain here. Anyway, you could do this. R equivalent is R1, R2 times R1 plus R2. Assume that this is not available in the market, and these are available standard resistors. Then, according to that formula, if you connect those two resistors in parallel, then you can get not available resistor in the market. So that is another advantage that we could say. That is the end of this video then. And